Hello everyone, my name is Boris from Weezenbeek. Today I'm going to explain how this pulse width extension circuit works. This is done for the course Creative Electronics. This circuit is designed to extend the duration of a short input pulse. When you press a button, the circuit's output remains high for a longer period before returning low. This is particularly useful in systems where short signals need to be detected by humans or other devices. The circuit is composed of several key components that work together to achieve the pulse width extension functionality. Although the diagram shows two op-amps, they are the same op-amp within the circuit. Now I'll go to each step in each component and how they interact. I'll start off with the button. This is our input device. When you press the button, it generates a short electrical pulse. This pulse is the trigger that starts the entire process. Following up the question, what's the effect of pressing and releasing the button? At the plus input of the op-amp. Pressing the push button generates a short pulse, which discharges the capacitor rapidly through the push button and R1. Cause the voltage at the intervening input of the op-amp to drop quickly. When released, the capacitor charges slowly to R2, causing the voltage at the intervening input to rise gradually again. Continuing to resistor 1 of 220 ohms. This resistor is connected in series with the push button. Its main role is to limit the current flow through the push button, protecting it from potential damage caused by the current or caused by an excessive current. And what's the function? So what is the function of the 220 ohm resistor in series with the push button? The 220 ohm resistor limits the current to the push button, protecting it from the current. Also so it can't skip the button due to too high current. So next we have the capacitor and resistor 2, the 470 kilo ohm resistor. When the button is pressed, the capacitor starts charging through the resistor. The rate at which the capacitor charges determines the duration of the pulse. Now continue to operational amplifier, also called the op-amp. It acts as a comparator. It compares the voltage across the capacitor to a reference voltage. When the capacitor voltage exceeds the reference, the output of the op-amp switches from low to high. The same op-amp then proceeds the signal further, ensuring that the output remains high for a specific duration even after the button is released. So what's the function of the op-amp? The op-amp functions as a comparator and signal processor, switching its output states based on the voltage difference between its interventing and non-interventing inputs and maintaining the output state for a set duration. Then the second question, what's the relation between its input and output voltages? The output voltage of the op-amp switches from low to high when the interventing input voltage is less than the non-interventing input voltage, also called the reference voltage. It switches from high to low when the interventing input voltage exceeds the non-interventing input voltage. Now I'll continue to resistor 3 and 4. Both are 10 kilo ohms each. These two resistors form a voltage divider. This sets a stable reference voltage at the non-interventing input of the op-amp. This reference voltage is needed for determining the threshold at which the op-amp changes its state, and the question at which input condition does the output voltage change value. So the op-amp changes output state when the output voltage of the comparator stage crosses a certain threshold. So the output goes high when the comparator's output is high and goes low when the comparator output is low, maintaining the extended pulse duration. Now I'll continue with resistor 7 of 220 ohms. This just limits the current to the LED, so it does not receive too much current, which can destroy the LED. Now go to the LED. This just provides the visual feedback. So when the circuit's output is high, the LED lights up, indicating the pulse which extends. Continuing with the transistor and resistor 8. The transistor acts as a switch, so when it receives a high signal from the op-amp, it allows current to flow through the lamp, which you see lighting up. And the resistor limits the base current of the transistor, so you can ensure proper operation without getting too much excessive current from the op-amp. Continuing with the question, what are the relevant properties you consider when choosing a bijunction transistor in a circuit like this one? For a bijunction transistor, the key properties are the maximum current it can handle, which should exceed the current to the lamp and resistor combination, and the voltage it can block off when off. Additionally, the gain and the base current required to switch it fully on are important to ensure proper operation with the given base resistor value. Continuing on to the last component, being the lamp. The lamp provides visual feedback similar to the LED. It lights up when its resistor is switched on, indicating the presence of a pulse or it's still extending. So ending off with a short summary. So when the button is pressed, it generates a short pulse. Then the capacitor starts charging, charges to resistor R2, increasing the voltage across it. Then the comparator action, the op-amp compares the capacitor voltage with the reference voltage from the voltage divider. When the capacitor voltage exceeds the reference, the op-amp's output goes high. And then the signal processing, the op-amp maintains a high output for a set duration after receiving the high signal from the comparator's configuration. And then, of course, how the lamp and transistor are controlled. The high output from the op-amp turns on the transistor, allowing the current to flow through the lamp and lighting it up. The lamp remains lit until the capacitor discharges below the threshold, at which point the output returns to low, turning off the lamp. This circuit ensures that a short pulse from the button press results in a longer stable output signal, which is indicated by the LED and the lamp. Let's continue with the last question. Which components determine duration of the extension period and why? The duration of the extension period is primarily determined by the RC time constant, which is the product of resistor R2 and the capacitor. This time constant controls how quickly the capacitor charges and discharges, thereby setting the length of the extended pulse. So thank you all for listening and have a nice day, evening, where you are right now.